Can someone please confirm if I'm audible?
Yes, sir.
Yes, sir.
Hello. Can you please confirm again?
Yes, sir.
Okay. So we shall start with the week 4 live session of the course Digital Electronic Circuit. So I am Anand Singhal, a PhD student from IIT Jodhpur, and I'll be assisting you in solving the assignment problems, which will help you in solving this year's assignment. Uh, so this is the course outline. So till now we have covered the introduction part of digital electronics and the Boolean algebra and minimization and all the basic concepts of SOP and POS. So in this week the course content will be mux, demux, encoders and parity generators. So we'll be talking about these topics in detail, and there will be again a detailed session of number systems in the upcoming week. So let's start with the tutorial problems. So this is the first question. So since these topics are quite easy, so try to be interactive and try to respond in the chat box, and please restrain yourself from opening your mic and camera in between. So this is a quite a simple question. So we'll start with this. So it says a multiplexer, and we need to choose the correct statements out of these four statements. First is, can someone answer this question? Please type in the chat box. And I request you to please be interactive in this session. Okay, someone has answered C. So let's see. So a multiplexer is nothing but a parallel to serial converter. So we have few select lines. We have a number of inputs which are multiple, and a mux converts those in multiple inputs into a single output. So we have n number of inputs. We have uh, nothing but log to the power 2n select lines, which comes from a formula 2 to the power m equals to n. So here m is the number of select lines and n is the number of inputs. So according to the first statement, which says selects one of the several inputs and transmit it to the single output. So a multiplexer is nothing but this only. It selects one of the several inputs which we have given, and corresponding to the input, it will select one of the input and give it as the output. So first statement is correct. Now the second statement says that it routes the data from single output to many outputs. So this is false. Since a mux only give a single output, so this statement is not true. Again, it says that it converts parallel data into the serial data. So yes, as you can see, there are several parallel data which we have fed into this multiplexer, and it is giving a single output. So this is also correct. And yes, our mux is a combinational circuit. So in the upcoming section you will be studying about sequential circuits and combinational circuits. I hope you know the basic difference, that combinational circuits does not contain any clocks. They don't have any memory basically, and sequential circuit have memory. Wait, yeah. So a mux is a combinational circuit. So the correct answer to this question is option C only. I hope it is clear. If you have any doubts, you can raise in the chat box. I'll give you a minute. Okay. So it was quite a basic question. I hope that you don't have any doubts. So I'll proceed. Again, okay. So this is question number two. So can anyone answer this question? It says how many 2 cross 1 multiplexer are required to generate 2 to the power n cross 1 multiplexer. Okay. Someone has already answered B. So we can do this question through some examples. So we know that there can be several mux such as 2 cross 1, 4 cross 1, 8 cross 1, which are nothing but 2 to the power n cross 1 muxes. So the question says that how many 2 cross 1 mux are required to generate 2 to the power n. So there is a basic terminology which is attached to it. So let's suppose we need to make a 4 cross 1 mux from 2 cross 1 mux. So there is a shortcut which can be applied here. So we just divide the number of inputs which are given to the mux with the number which we want to convert it to. So let's suppose here we have taken a 2 cross 1 mux. So we'll divide the number till we reach to a finite single integer. So we'll divide this 4 by 2, which will be 2, and then we again divide this 2 by 2, so it is 1. So whatever the numbers will be here, so adding those will give the output. So for a 4 cross 1 mux, you can see 4 by 2 is 2 and 2 by 2 is 1. So we require 3 mux, 3 2 cross 1 mux basically. And similarly, we can check it for 8 cross 1 mux. Can anyone tell how many mux are required for 8 cross 1? Anyone? Yeah. So it will be 4 plus 2 plus 1, which will be 7. So as you can see for 2 to the power n, when n is 2, the output was coming as 7. Let's suppose output is O. Sorry, the output is coming as 3. For n equals to 3, the output is coming as 7. So if we generalize this, it will be nothing but 2 to the power n minus 1. So if you put n equals to 2, it will be 3. If you put n equals to 3, it will be 7. So the correct answer to this question is option B. Is there any doubt in this? Shall we proceed? Okay. So this is again there are few questions which will we will be doing for converting a higher order mux to a lower order mux. So maybe you can draw a block diagram for this question. So it says you need to construct a 16 cross 1 mux using a 8 cross 1 and a 2 cross 1 mux. So I hope it is doable now. I'll try to do it and you can do it in your copy. So this is a 8 cross 1 mux. So it will have certain outputs. Uh, Let me write it here. I3, I2. Yeah. So this will also have 8 inputs. So this will combinedly give some 16 outputs, and this will be nothing but 2 outputs. So we can make a 2 cross 1 mux using that. So this will be nothing but 16 input and single output. So this is how we have converted a 16 cross 1 mux using 8 cross 1 and 2 cross 1 mux. Is it fine? Okay. So these are few simple questions that we have covered till now. Okay, so now the similar concept can be applied to a demultiplexer. So it will be nothing but reverse of a mux. Let me try. So a demultiplexer is nothing but it has a single input and multiple outputs. It is nothing but one cross. Let's suppose the question says n outputs, and it has 2 to the power m select lines. So the question says what is the number of select lines required in a single input and n output demux. So we know the relation between uh, select lines and number of inputs. So it is nothing but 2 to the power m select lines are there, and which is equal to the number of inputs. So if we take log both sides, so it will be log to the base 2 to the power m equals to log to the base 2 n. We know that log a to the power b is nothing but b log to the power a. So using this property, we can write it as m log to the power 2 is log to the power n. And we know that when base and the inside value is equal, it is nothing but 1. So m equals into 1 is nothing but log to the power n. So number of select lines will be m, which is nothing but log n to the base 2. So the correct answer to this question is option D. I hope it is clear. These are quite simple questions. Here we have considered number of select lines as m, number of outputs as n, and the relation is nothing but 2 to the power m is n. From this we have calculated this. Is it fine? I'll try to explain again what we have covered till now. So a multiplexer, we have seen that it is nothing but uh, a serial or a parallel to serial data converter, and it has multiple outputs and a single output, multiple inputs and a single output. So using the concept, we have also covered uh, that how can we convert large multiplexers, or how can we make the multiplexer which have larger number of inputs using the multiplexer which have a lesser number of inputs. So this is a basic shortcut that we have applied, that we need to divide the larger number with a smaller one, and ultimately we need to add those numbers. So we also got a general relation, which is if we have a 2 to the power n cross 1 multiplexer, we'll need 2 to the power n minus 1 multiplexers, which are 2 cross 1, to generate those higher order multiplexers. Then we covered, this was again the same concept, that how can we make a 16 cross 1 using smaller number of input multiplexer. So it was nothing but we have made a block diagram, and it is quite clear that we have 16 inputs and a single output using two 8 cross 1 and one 2 cross 1 mux. Then the similar concept we have applied for this demux. Demux has m select lines and n number of outputs, since it has a single input. Input is single here. So we have m select lines and n outputs, and the relation is given by 2 to the power m is nothing but the number of outputs, which gives the number of select lines as log n to the base 2. Shall we proceed now? Anyone? Okay. So these are again few questions which are dependent upon the relations that we have derived. So maybe you can answer it quickly. We need to find the 2 cross number of 2 cross 1 mux required to implement this 16 cross 1 mux. Can anyone answer? Can anyone answer it quickly? I'll give you a minute. Okay. So using the terminology that we have used earlier, let's see. So we need to convert 16 cross 1 to 2 cross 1. So we need to divide these two numbers. It will be nothing but 16 by 2, which will be 8, then 8 by 2, which will be 4, then 4 by 2, which will be 2, and then ultimately 2 by 2, which will be 1. So if we add this, we'll get nothing but 15. So the correct answer to this question is option A. If you have any doubt, you can ask in the chat box. We'll proceed in 2 minutes. Okay, I guess we have one more question which is similar to this. So you can try this. It is some larger number. So yeah, you can tell me the answer for this question. I'll give you maybe 5 minutes for this. Anyone? It's just simple mathematics. Okay, someone has answered 170, which is option D. Okay, one of the answer is 170. Okay, someone else has answered 171. Okay, we'll see which is correct. It is a simple mathematics. Anyone else with some other answer? Okay, let me try to solve it now. If half is there, yes. I'll let you know what is the problem. So we will have to make 512 cross 1 from 4 cross 1. So we'll start with 512 and divide it by 4. So it will be nothing but 1 is 3 8, sorry, 128. So 128 by 4 will be nothing but 32. Then 32 by 4 will be nothing but 8. Then 8 by 4 will be nothing but 2. Then 2 by 4 will be nothing but half. So this half means that the last multiplexer that we will require can be a 2 cross 1 mux, because we only need half of the inputs of that. So since we have only 4 cross 1 multiplexer, so we need to take this as an additional one. We will only use two inputs of the 4 cross 1 mux, but we need to take an extra mux for that. So if we add on these numbers, it will be nothing but 128 plus 32 plus 8 plus 2 plus 1. Okay, can anyone tell what is it? It is nothing but 130, 168. Yeah, so it is 171, which is option B. So I hope now you know that half means that we can make it using a 2 cross 1 mux also, the last input. But since we only have 4 cross 1 muxes, so we'll use two of the inputs of the 4 cross 1 mux. So we need to take an extra 1 mux. So that is why the answer is 171, not 170. Is it clear now? So this is the answer. I'll write the answers again. So here it was A, here it was D, uh, here this is just a block diagram. Here it was B, and here it was C. Yeah, I hope it is clear. If it is clear, please respond that it is clear. Uh, okay, we'll proceed in a minute. We'll have some complex question of multiplexer also, which will need certain amount of time to get solved. So they will help in solving you the assignment. So please be patient. I am clearing the basic concepts right now. I'll be having some time consuming question also. So be prepared and try to be interactive. Let's proceed now. Okay, you guys also try this question. I'll give you 5 minutes for the question. So it says that how many, yeah, wait, how many 2 cross 1 mux are required to implement 2 input NAND gate? So NAND gate, I'll let you know the basic. NAND gate is nothing but A dot B whole bar. So it is covered in previous weeks also. NOR gate is nothing but A B, and it is nothing but A plus B whole bar, which is nothing but A bar into B bar. And then XOR gate. XOR gate is nothing but A B. So the output for this is A B bar plus A bar B, or A XOR B. Let's suppose Y is the output. So you need to tell me that how many 2 cross 1 mux are required to make these gates. And yes, one of the main thing that I need to add here is mux is a universal gate. Universal, yeah. Using mux, you can derive any logic or Boolean expression. Since we know that NAND and NOR gates are universal gates, I hope you know that from the last sessions. So we can make those gates using a multiplexer also. So that is why we call mux also as a universal thing or a universal circuit. So yeah, I hope you are trying this. Okay, so someone has already solved option C, I guess. Okay, we'll check. One of them is answering as option C. Is there any other answer? I'll give you 2 more minutes. Don't worry. Anyone? I'll start in a minute if you don't have any answer. Okay, I'll give you a hint. So I'll solve for this NOR gate first. So we know that for a NOR gate, we require output which is A bar dot B bar. So we know that for a mux, 2 cross 1 mux basically, we'll take one as select line and it is nothing but 0. So this okay, this corresponds to A bar and this corresponds to A. So we need to have A bar into B bar. So if we certainly have A bar as the output of this mux, we can multiply it with the one of the select lines of this. Let's suppose this is 0 1, which this will corresponds to B bar, this will corresponds to B. So if we can connect this A bar to this B bar and take this as ground, we can have output A bar dot B bar, which will be nothing but a NOR gate. So let's see how can we do it. So to get the output of A bar from this mux, we need to give 1 and 0. I hope you know that this 1 corresponds to VDD and the 0 corresponds to ground. So it is nothing but A bar into 1 plus A into 0, which will ultimately give you A bar. Uh, so the output of this section will be nothing but A bar. Now A bar is connected to this second mux and we have connected ground to this, so it will be nothing but A bar into B bar plus 0 into B. So this term will get 0 and we'll get A bar dot B bar, which is nothing but a NOR gate. So for NOR gate we required uh, wait, 2 2 cross 1 mux. Similarly you can do it for NAND and XOR. If you're not able to do it, I'll make the logic. Shall I do it or you are doing it? I can give you 2 minutes if you want. You can tell if you want me to do it right now. Shall I proceed? Okay. So I'll try to make NAND gate now, which is nothing but A bar plus B bar. So let me use some extra page. Yeah. So now the objective is A bar plus B bar. This will be nothing but our NAND gate. So if you take 2 cross 1 mux, we'll get certain output. And we require this as A bar plus B bar. It will be A, it will be B. So I hope you know the basic properties of Boolean algebra. I'll try to write some of the properties. It is commutative, it is distributive, and there are certain theorems which are a plus a bar b is nothing but a plus b. Uh, ab plus bc plus a bar c is nothing but ab plus a bar c. And there are a few more, so we require basically this theorem in this. So what we'll do is we'll apply, we know that this is 0 1 0 1. So this will be a bar, this will be a, this will be b bar, this will be b. So if we take, let's suppose 1 here and 0 here. So this will give nothing but a bar. I hope it is clear. This is similar to the NOR one. So it, it is nothing but a bar into 1 plus a into 0. So it will give a bar. Now if we use a bar, we have b bar, we have. If we use, okay, so let's suppose we connect this. I'll try to rub this. Yeah. So let's suppose we connect this a bar to this b, and for b bar we give it as 1. So this will be nothing but a bar. Oh, this will be nothing but 1 into b bar plus a bar into b. I hope it is clear. It is nothing but b plus b bar a bar. So can anyone tell what will be the answer using this property? You can replace a with b and b with a, so it will look similar to you. Oh, I've written it wrong. It is b bar plus ba. Yeah. So anyone, can you tell what will be the output using this property? So it is written as b bar plus ba. Okay, so someone is saying a bar plus b bar. Yeah. So this is correct, that it will corresponds to b bar plus a bar, which is nothing but a bar plus b bar, since it is commutative. And this is nothing but a NAND gate. So how did it come that a plus a bar b is a plus b? I've just told you. So replace a with maybe x bar and b with maybe y bar. It will be nothing but x bar plus x bar bar and then y bar, which will be nothing but x bar plus x y bar. And if we do it on the RHS, so it will be nothing but x bar plus y bar. Is it clear? The NAND gate? Please respond if it is clear. Okay. So for NAND also we require two mux. So can anyone tell? Okay, let me go back. Yeah. So can anyone tell for the XOR gate, what will be the inputs to the two muxes? I'll make it maybe here. Sorry. So yeah, I'll make two mux here. There is one select line which is A. There is one more select line which is B. And yeah, so there are two muxes, and this will be the final output, and it is nothing but a b bar plus a bar b. This is 0 1 0 1. Can anyone tell what should I write here so that we can get a certain output? First of all, can you tell for these two? Anyone? You need to make this logic a b bar plus a bar b. So can anyone tell what do I need here? First of all, these two blocks. What will be the output of this mux? If you will not answer, I'll start in 1 minute. Don't worry. Anyone? Okay, let me try to do it. So let's suppose we want to take a bar as the input of this mux, and so I'm writing maybe 1 here and 0 here. So this will give nothing but a bar into 1 plus a into 0, which is nothing but a bar. And I'm connecting this a bar to this, yeah. And then I'm connecting this select line to this. Okay, I've connected it in a wrong manner. Yeah. So I need B bar with I and A. So I need to connect this select line to this, and A bar is the output of this circuit. So I'll connect it here. So this is B bar, this is B. So when I try to take the output, it will be nothing but A B bar plus A bar B. I hope it is clear. Let me write it somewhere else, which is, yeah, maybe I can write it here. So what I've done is I have taken the output as A bar from this mux, and this select line I have connected to the secondary mux with a 0, that is B bar, and this A bar I have connected with 1, which is B. So the ultimate output which is coming is A B bar plus A bar B. It is nothing but XOR gate. Is it clear? Please respond if it is clear. Okay, so for XOR gate also we require two. So the correct answer was C only for this question. I hope the whole question is clear because this is quite important concept. You need to realize different expressions in your assignment problems using this multiplexer. So I hope it is clear to you. We can wait for a minute, then we can proceed. If you have any doubt, you can straight away write. I can explain it again. Uh, okay. Shall we proceed? Okay. Yeah, you can try this question. It is similar question. So maybe you can tell me what is the answer. I'll then solve it. There are certain inputs which are given to the mux. Certain select lines are there. You need to check them carefully. And then the output of this mux is fed to the this second mux, and we want to calculate x. I'll give you maybe 2 minutes or 5 minutes if you want. And now I want everyone to respond so that it I can see that it is clear to all the students. Anyone with any option? Okay, so one of them is getting A. We'll see. Let me proceed. So we can see that the select line for this is A and B. So this will be nothing but a bar b bar, a bar b, a b bar, and then a b. I hope this is clear. This is nothing but 0, 1, 2, 3. So if I try to solve this, so this both will get cancelled and it will be nothing but the output y. Y will be nothing but a bar b plus a b bar, which is nothing but a XOR b. Now this a XOR b is given to both of these terminals. So I can see that it is b bar c bar, b bar c, b c bar, and b c. So if I try to simplify it, since both of them has b XOR c as the input, so if I try to calculate x, it is nothing but x is nothing but, maybe I'll write as a b bar plus a bar b. Then it is multiplied with b bar c, and then again a bar b plus a b bar. Then it is again multiplied with b c bar. I hope it is clear. Is this step clear? Anyone? Is this step clear? Okay. I'll try to proceed. So if I multiply b with b bar, you know that we will get 0. Maybe I'll try to write it plus a b bar c plus a bar b b c bar plus a b bar b c bar. So we know that this is 0 and any variable multiplied with 0 will give always give 0, and x bar is nothing but 0. So using these two properties, this will get 0 and maybe this will get 0. So ultimately, and x into x is nothing but x. So b bar will be a single b bar, a b bar c plus a bar b c, a b a bar b c bar, and then yeah. So the correct answer is option C here. So someone has written something else, I guess. Okay, so option A is not the correct answer. Option A would have been the correct answer if this select line would have been one, or yeah. So then this would have been C and C bar. Then it would have been A XOR B XOR C. So you have to look carefully. The select line was B C, not only C. So that is why the answer is not A XOR B XOR C. Is it clear? Yeah. So the correct answer is option C here. We'll proceed in 2 minutes. So if anyone is having any doubts, they can ask right away. Any doubts, students? Shall we proceed? Okay. So now again you can try this question by your own. It says that which of the following shows the correct representation of OR gate using multiplexer. So OR gate, I hope you know. OR gate is nothing but this F should be A plus B. So we can check it quite easily using different options. So maybe you can do it by yourself and tell me which option is getting. We are getting this A plus B as the output. I'll give you 2 minutes for that. And do try to remember these properties. I'll write again. A into A bar is nothing but 0. A plus A is nothing but A into A is nothing but A plus A bar is 1, then A plus A bar B is A plus B. Yeah, this will, I guess, cover all these things. Anyone with any answer? So we need F as A plus B. So is there any circuit which is given, which is giving this answer as anyone? I'll give you 2 minutes, okay? Okay, option A. So we can start with option A if someone has answered. Let's see this circuit. Option A is nothing but if we write 0 is A bar and 1 is A. Again, this is A bar and this is A. So the output of option A will be A into B, and then F will be nothing but A, A bar, B plus A. So A bar, we know that I've written that it is 0, and 0 multiplied by anything will be 0. So this term will be 0 into B plus A. This will be 0 and B will get F as A. So this is not the correct answer. So option A is not correct. So you can try to solve again for some other option. We need F as A plus B, which is a combination of OR gate. Let me try to solve with option B. So option B, maybe I can write here. So yeah, option B says this is nothing but A bar. This is nothing but A. This is okay. So this is the select line. So let me try to calculate it. This will be A bar into 0 plus AB. I hope it is clear. So the select line to this mux will be AB. So 0 will be AB whole bar and this will be only AB. So for option B, F will come as AB whole bar into 1 plus AB into 0. So this will term will get cancelled and the answer will be A into B whole bar, which is A bar plus B bar. So this is a uh, NAND gate, not a AND. So option B is also incorrect. Anyone has come up with any answer till now? Okay, let me try option C then. Try to solve side by side. Please try to be interactive. So option C is nothing but this is A bar, this is A, again this is A bar, this is A. So the output of this circuit will be, since it is 0, so this will be A bar B. Yeah. So A bar B. So for option C, F will be nothing but A bar B into A bar plus this is A only. This is A bar, this is A plus A. So A bar will be if we multiply same with same variable, so it will be A bar B plus A. So if I try to write it, maybe A plus A bar B, and we know the property that A plus A bar B is nothing but A plus B. So yeah, this is the OR gate that we were required to solve for. So option C is the correct answer. Option C is correct. Can anyone tell the expression for option D? You can solve it quite quickly if you can. I'll give you 2 minutes if you can give me the expression for option D. What is the final F? Anyone? Can you give me the expression for option D for F? We already know the answer to this question is option C, but I want you to solve F for option D. Anyone? Okay, someone is written A bar plus B. So let me check. So this is nothing but B bar and this is B. So the output of this circuit will be, since it is A B bar and this is 0. I hope this is clear. A B bar. The select line will be A B bar. So this will be A B bar whole bar and this will be A B bar. So if I try to solve this, since it is 0, so the only output that we'll get at F will be A B bar whole bar. Okay, let me try to undo it. So for option D, F is A B bar whole bar. On solving, we'll get as A bar plus B. Yeah, so it is correct. The whatever you have calculated. So it is not an OR gate, but this is one of the question that we have added. Not an OR gate. So the correct answer to that question was option C only. Fine. I hope it is clear. The question required that we need to implement this OR gate using the multiplexer. So we have checked for all options. Only option C is giving the logic for OR gate. Is it fine? Shall I proceed now? Or is there any doubt? Okay, so I'll proceed. Yeah, so you can do this right away. So we need to implement a function which is, I hope you have already read minterm and maxterms, using a 8 cross 1 multiplexer. So maybe side by side you can tell 1, 2, 3, 4, 7, 8. So I'm using A, B, C as select lines. So we require at output we require what we require 0, 1, 5, 6, 8, 10, 12, and 15. So if I try to expand it, it will be A bar, B bar, C bar, D bar. Then 1 will be 0, 0, 0, 1. And 5 will be A bar, A, B bar, C. And then, okay, I written it incorrectly. So 5 will be 1, 0, 1. 1, 0, 1. Then 6 will be 1, 1, 0. Then 8 will be 1, 0, 0. Then 10 will be, I hope it is clear what I'm doing right now. So 10 is nothing but 8 plus 2. So it will be, yeah, 0, 1, 0, 1. It was 5, it was 6, then it was 8. So 10, 8 plus 2. Okay. So 10 I have written wrong. 8 plus 0, 0, 0. What is wrong here? Okay. This is not it. So even 8 is 1, 0, 0, 0. Yeah. Then for 10 we have A, B bar, C, D. Then for 12 we have A, B, C bar, D bar. And for 15 we have A, B, C, D. Is it clear, the all the terms that I have written? This is 0, this is 1, this is 5, this is 6. Anyone please confirm that I have written all of them correctly. 8, this is 10, this is 12, and this is 15. So if I try to write all the terms here, which is a 0, 0, 1, 0, 1, 0, then 0, 1, 1, then 1, 0, 0, then 1, 0, 1, then 1, 1, 0, and then nothing but 1, 1, 1. Is it clear? For 10 it is not correct. Okay, let me see. For 10 it is which color I was using. So 10 it is 8 plus 4. Oh, okay, yeah, this will be bar. Fine, thank you. Yeah, thank you for the clarification. So we can see here how we can solve this. See that for a bar, b bar, c bar, there is a single term and it contains both d and d bar. So if we try to take it common, then this will be 1. I hope this is clear, the thing that I have done right now. So if I try to take a bar, b bar, c bar as common, so it will be d plus d bar. So we need to put 1 as the input of a bar, b bar, c bar to get both these terms. Then we can check is there any term for a bar. So there is no term. Then a bar, b, c bar. So yeah, there is one term. Yeah, there is only one term. So we need to subtract d here. Then a bar, b, c is here. So there is only one term. So we need to subtract d bar here. Then a, b bar, c bar. We need to subtract d here, d bar. Then a, b bar, c. We need to supply d bar here. Then a, b, c bar. We need to supply d bar here. And for the last, we need to supply d. I hope it is clear. So this will give us the output of this as. Is it clear to everyone? Please respond. Please respond, everyone, if it is clear. So this is I7, I6, I5, I4, I3, I2. Okay, sorry. Order is wrong. I0. Sir, this is. Yes. So we are using select line as ABC and we can use D as the input of the mux. So yeah, this is D as entered variable. You can try it in the reverse section now. You can use this as select lines and try to make a logic out of it. So you will get these min terms only. Is there any doubt? Do I need to explain it again? I can do it. Should I explain again or should I proceed? You can type in the chat box. Okay. Okay. So this is nothing. Yeah. So there are few basic questions now for mux. So give me the answer as soon as you can. So this is a basic circuit. So we need to calculate what is F here. Anyone? This is quite basic. Anyone, please? Okay, one of them is saying option B. Any other answer? Anyone else? Okay, so let me try to solve it. So we know that this is x, and so 0 will be x bar and 1 will be x. So the output of this circuit will be x bar into y plus 0. It will be nothing but, okay. So here it will be x bar y, and the node of this will be x bar y whole bar, which is nothing but x plus y bar. So if I try to solve it now, so f will be x bar y into z bar plus x plus y bar into z. Is it clear this step? Is this step clear? Please respond if it is clear. Okay, so f will be nothing but x bar y z bar plus xz plus y bar z. Yeah, so this is option B only. So option B is the correct answer. Okay, I'll repeat. Okay, let me try. Yeah. So as you know that 0 is nothing but x bar and this is x. So here let's suppose this is f1. So f1 will be x bar into y plus x into 0. So this term will be 0. So f1 will be x bar y. And then the not of f1, let's suppose it is f2. So here it is f1, here it is f2. So f2 is nothing but xy ka not. So it is nothing but x plus y bar. So is f1 and f2 clear? Uh, can you please respond if f1 and f2 are clear? Okay, so now what I'm doing is this final f is nothing but f1 into z bar and f2 into z. Is it clear? You can respond. Okay, so f1 is nothing but x bar y, which is into z bar, plus f2 is nothing but x plus y bar into z. So this is what I have written here. Okay, try to undo it. Yeah. So this is what I have written here. Is it clear now? So this is the final answer. If it is clear, you can respond if it is clear. So option B is the correct answer. Shall I proceed now? Okay. Okay. So yeah, you can maybe do this. So what we need to do, we need to use a 4 cross 1 mux. We have certain outputs. Okay. I0, I1, I2 and I3, and it says that we need to calculate these four values for a function a, b, c, d, and a and b are the select lines. So I1, I2, I3 and I0 will be in terms of c and d. So I n will be a function of c and d. We are using these as select lines, and the final output given by this is nothing but minterms 0, 1, 3, 4, 6, uh, 10, 11, 12, 13, 15. So let me try to change the color. So this will be nothing but a bar, b bar. This is a bar b. This is a b bar, and this is a b. So first we need to expand this. So I'm slowly writing all the terms. Maybe you can try side by side. So first one will be a bar, b bar, c bar, d bar. You can tell me if I have written anything wrong. Then this will be d. Then it is 0, 0, 1, 1. Then 4 is 0, 1, 0, 0. Then 6 is 0, 1, 1, 0. And 10 is 1, 0, 1, 0. 11 is, okay, I've written it wrong. 1, 0, 1, 0. This is 11. Hmm. 1, 0, 1, 1. 12 is 1, 1, 0, 0. 13 is 1, 1, 0, 1. 15 is 1, 1, 1, 1. Is it clear? Uh, have I written anything wrong? This is 0, this is 1, this is, okay, let me try to undo it. This is 0, 0, 1, 1, this is 3. Why is it happening? This is 4, this is 6, this is 10, 11, 12, 13, and this is 15. Is it clear? Anyone? Okay, so now I'll try to solve it. So for a bar, b bar, we'll try to collect the terms. So let's suppose I naught, we have a bar, b bar already. So this term, and this term has a bar, b bar. So this is c bar, d bar plus c bar, d plus c d. So if I try to solve this and try to take common c bar, it will be c bar, d bar plus d plus c d. This will be nothing but c bar plus c d. And from the property, no, we know that this will be nothing but c bar plus d. So we got the I naught. Uh, C bar plus D. So yeah, I naught is C bar plus D. Similarly, we can calculate for I1 and I2. So I'll do it right away. So I1 will be A bar B we already have. It will be C bar D bar plus C D bar plus C D bar plus, okay, only this. If I try to take maybe D bar common from this, so it will be C bar plus C, and this will be 1. So I1 will be nothing but D bar. Is it clear? These two? please respond if it is not clear or clear. We have calculated, okay, we have calculated I1, now we'll calculate I2. So I2 we need AB bar. Yeah. So AB bar is, let me see. Yeah. AB bar we have CD bar plus CD plus, okay, we have these two only. We can calculate, we can take common C from this. It will be D plus D bar, which will be 1. I2 will be C. Is it clear? Anyone? Okay. And for I3, we have AB by default, then, okay, what is this? C bar D bar plus C bar D plus CD. So if we take C bar common, then it will be C bar plus CD, and then it will be nothing but C bar plus D. So this will be I3. So if I try to check the option, so this is I1 C bar plus D, this is I3 C bar plus D, and I1 is D bar and I2 is C. So okay, C bar plus D, C bar plus D. Okay, so these two can be correct. Then what was the option? So I1 is D bar. I1 is D bar. Yeah, so A is the correct answer, right? Hmm. Is it fine? So for the correct answer is A. Okay, I'll proceed in 2 minutes. Let's see next question. Maybe I can give you. Okay. So yeah, this is one of the question. Maybe I can give you a hint. So you need to calculate the values of these inputs such that f follows the sum of inputs. So follows the sum of inputs is nothing but XOR gate. So this is a terminology that we write for XOR gate. Follows the sum of input implies XOR gate. So I have told you few shortcuts in the previous session also. So we know that summation of midterms 1247 is nothing but an XOR gate. Then I also told you that summation of 3, 5, 6, 7 was nothing but a majority gate. So majority gate is nothing but AB plus BC plus AC. Then XOR gate we already know it is A XOR B XOR C. So for this you need to calculate functions such that it is giving A XOR B XOR C. So you need to calculate the value of these. So we need to check for all the options. So you can check for option A. Okay, you have already got the answer. Option A is giving this. Fine, we'll check for option A directly if it is giving this. So yeah, let's proceed then. So I'll write it here 0 1 1 0 1 0 0 1. So 0 is getting 0 and this. So this is C. Then C bar. Again this is C bar and this is C. Is it clear this step? Is this step clear? Please respond if it is clear. No, sir. Okay. So you can see that I have written option A as the input 0 1 1 0 1 0 0 1. So if you can see this mux, so I'm drawing it here. It is vertical 0 1. The select line is C and the output is something. So we notice 0 is nothing but C bar and this is C. So I'm taking this as C bar into 0 plus C into 1. This will get 0, so the output will be C for this mux. And similarly we can do for all the muxes. So here it is 1. Oh, so oh, so here it is 1. What is happening? So yeah, here it is 1, so C bar will be here and C will be here. So C bar will be the output of this. So similarly for these two also. So 1 is here, so C bar will be here, and 1 is here, so C will be here. Is it fine? Uh, okay, yeah. So similarly, I'll write it for this. So here it is B bar, here it is B, here it is B bar, here it is B. So if I try to calculate the expression for this, it is nothing but B bar C plus B C bar, and here it is B bar C bar plus B C. Is this step clear? This is quite important, so please respond if it is clear or not. I can do it again. Is it clear? Okay. So now it is A bar and A, so I'm writing the final expression maybe on the next page. So, okay, wait. So F is nothing but B bar C plus B C bar. It will get multiplied with A bar plus B bar C bar plus B C, and it will get multiplied with A. So is this F line clear? That how it has come? Anyone? Okay. So if it is clear, so now I'm just opening the bracket. So one term will be A bar B bar C. Second term will be A B C bar. Okay. Then the third term will be A B bar C bar, and then it will be A B C. So if I try to write the uh, decimal representation or the min terms representation, so it will be 0 0 1 is 1. This will be 0 1 0, which is 2. This is 1 0 0, which is 4, and 7. So I've just told you the shortcut, uh, which is this 1247 is XOR gate always. So this is nothing but F summation minterm 1247. So yeah, it is following the input. So the correct answer to this question is directly option A. So we have checked for one option only and we have got the correct answer. You can check for these three also. You will not get the same expression. So the correct answer to this question is option A. What is wrong with this? Option A. Is it clear to everyone? Please respond. Okay. So I'll proceed in 2 minutes. Few questions of parity are there. You can do it side by side if you want. I'll proceed in 2 minutes. Okay, someone has already gotten this answer. We'll check. Okay, so the first expression says that for more than two input XOR gate, output is 1 if there are even number of ones. Okay, so it is only true when we have even number of XOR gates. It is not true for all the XOR gates. So, sorry, if we have odd number of XOR gates. So for three XOR gates, the output will be 1 when we have, sorry, so even only, right? When we have even number of XOR gates. So let's suppose for three, we know that for three input XOR gate, if I try to make the truth table, let's suppose for one case only, which is 0, 0, 1, so output is 1. So here we have odd number of XOR gates and we are getting output of 1. So this statement is not correct. So option A is not correct. Even parity refers to the presence of even number of ones. Yes. So this is correct. This is what even parity means, when we have even number of ones in the bit patterns, and odd parity means when we have odd number of ones. Then parity generation and checking involve multi-input XOR gate circuit. So it is not always true. We can have XOR circuit, not XNOR gate circuit for the parity generation. So option 3 is also incorrect. Then 4 says that parity check is useful in detection of error. Yes. So this is a whole topic named information theory, where we do this parity generation and detection of error. So option 4 is also correct. So the correct answer to this question is option C. I'll try to write it with some different. I hope it is clear. It is a theoretical question. So option B and this option 2 and 4 are correct, and 1 and 3 are wrong. The correct answer is option C. Is it fine? Shall I proceed? Okay. So again, we have a decoder question. Maybe you can solve it in 2 minutes. I'll give you 2 minutes. So we need to make a three cross. Sorry, from 3x8 decoders, we need to make a uh, 6x64. So decoders also have similar logic as I told you in uh, demux. So you can try 64 and 8 for the same and tell me what is the number. Okay, someone has got 9. Yeah, this is quite easy. 64 by 8 is 8, then 8 by 8 is 1. So yeah, 8 plus 1 is nothing but 9. Is it clear? It was quite simple. The correct answer is option A. Is it clear to everyone? Please respond. Is it clear? Okay. So maybe I'll proceed. Again, a simple question. So maybe you can tell the answer to this. It is again a 1 minute question. So the question says that 5 cross 32 needs to be implemented with some 3 cross 8 and 2 cross 4 decoders. So can you tell me how to do it? Again, you can start with the larger number and then divide. So option D says that 8 2 cross 4, and option other option says that 3 cross 8. So we need to check for both the options. So let's suppose we are using 4 decoders, 2 cross 4 decoder, then it will be 8, then 8 by 4 is 2, then 2 by 4 is half. Half means 10, 8, 10, 2 cross 4. Okay, so this is incorrect. We require 10 directly, and then 1 cross 2 decoder also, which is a NOT gate. So this is not correct. So we need to check for 8 only. Is there anyone with the answer? Okay, option A you are saying. So we will check for 8. 32 by 8 is nothing but 4, and then 4 by, okay, 4 by 8 is nothing but half. So half means we can do it a bit lower. So 2 cross 4 here, and 4 3 cross 8 here. So yeah, option A is the correct answer. So we require 4 3 cross 8 decoders and 1 2 cross 4 decoders. I hope it is clear. It is quite easy. Is it clear to everyone? Please respond if it is clear so that we can proceed in 1 minute. Anyone? Okay, let's proceed. There is. Okay, so maybe you can tell me this answer also. So there is a circuit, select lines are A and B, and here it is the input of this, and here it is C. So you need to calculate X. This is quite easy. So just tell me the answer. Maybe I can give you 2 minutes for this. Okay, so someone has got A as an answer. Anyone else with some different options? So one option is A. Let me try to solve it. Okay, again A. So for the first, which is Y, so I'm calculating for Y. It is nothing but this will be A bar B bar, A bar B, A B bar. Then okay, sorry, and then A B. So Y will be nothing but A bar B plus A B bar, and then it is applied to one of the select lines. So it is A B bar plus A B bar. Sorry, A bar B plus A B bar. So if I try to write, it will be nothing but, okay, I'll try to write I1 of this as here. I1 will be nothing but A pole bar into C. I1 will be A into B bar. Okay, sorry. So this will be I2. Okay, I1 is 0, 1 only. No, this will be I1 only. I2 will be A bar B plus A B bar into 1, 0. Yeah. So X is nothing but I1 plus I2. So if I try to open this, it will be nothing but A plus B bar into, this will be nothing but XOR X XNOR. So the expression will be AB plus A bar B bar into C plus A bar B C bar plus A B bar C. So final expression will be A B C plus A bar B bar C plus A bar B C bar plus A B bar C, which is option uh, A bar. Is there any option matching to this? Okay, a b bar c, a bar b bar c, a bar b bar c bar, 0 1 and then 1 0, a bar b c bar, a b bar c bar. Okay, so this is a b bar c bar, then this is a b c. Yeah, a b c is there, then a b bar c bar is there, then a b bar c is there, and then what is this? Okay, so yeah, option A is the correct answer. Sorry, I wrote is this as wrong. So option A is the correct answer. I hope it is fine. So it was C bar, not C. So one of the term will be ABC, which is 7. One of the term will be 001. Then this term will be 010, and then this term will be 100. So it was nothing but an XOR gate only, 1247. So this is an expression for XOR gate. So option A is the correct answer. Is it fine? Shall I proceed? Okay. So you can solve for this. We need to give the POS expression from this. So can anyone tell? POS expression means in terms of pi, not in terms of summation. Summation this means SOP, and then pi, uh, which in terms of max term means POS. So we know that the complement of this min term is nothing but max term. So we can calculate the min terms first, and then rest of the remaining numbers will be the POS expression. So let me try to solve it. So here it is A, here it is A bar, then 1 0. So here it is B bar C bar, B bar C, B C bar, and then B C. First term F will be A B bar C bar plus A bar B bar C plus 1 into B C, and then last will be U. So I'm writing A plus A bar here as common so that I can get all the minterms. A bar B bar C plus A B C bar, then A bar B C bar. So this is nothing but 100, which is 4. This is 001, which is 1. This is 110, which is 6. And this is 010, which is 2. So F is nothing but summation of 1246. So if I write the max term out of it, there will be nothing but 0, 1, 2 is there, 3, 4 is there, 5, 6, 7. Is it fine? The answer to this question is this. F is this. So the POS expression is pi m 0357. Is it fine? Please respond. Okay. So we can proceed now. So you can try this also. It says that input of a 4 cross 1 multiplexer is okay. So we need to make Q as XY plus Z, and X is the MSB and Z is a okay, and XY are the select lines, and this D will be a function of Z. So D3 is the maximum number. So I'm writing here XY, then uh, XY bar, then this is X bar Y, and this is X bar Y bar. So you need to calculate this d3, d1, d2, d1, and d0 in terms of z, so that we can get q as xy plus z. So I'll try to expand this xy. So z plus z bar. Maybe I can take first as y. So xyz plus xyz bar. I'm doing this to just get the min terms out of it. So this is yz plus y bar z. Again, I'll expand it. Uh, xyz plus xyz bar. Then x plus x bar. So xyz plus x bar yz and x y bar z plus x bar y bar z. So it is nothing but 7. This is 6. This is again 7. This is 0, 1, 1, 3. Then it is 5, and then this is 1. So it is nothing but summation 1, 3, 5, 6, 7. So we can easily get this. So for xy, what we are having, xy, we are having z. So d3 is z. Then for xy bar, we are having this term only, which is z. Then for d1, we are having x bar y. X bar y is this. Hmm. So we are having z again. And for d0, we are having x bar y bar. So which is again z. So d3 is z, d2 is z, d1 is z. Okay, I've written something wrong here, I guess. xy z plus z bar, then xyz plus x bar yz, and then okay, x bar y bar is z, then x y is okay. So x y is 2 times, so it is 1. D3 is 1. So D3 is 1, and then D2 is x bar x y bar, which is z, then this is z, then this is z. Yeah, so d3 is 1 and rest of them are z. Sorry for the glitch. Okay, I need to undo it, I guess. Okay, so I guess for this the calculation has gone. So I was getting d3 as 1 and rest of them as z. I hope it is clear. The calculations have been erased, so they are deleted. So option A is the correct answer. I hope you get it. Should I solve it again? Okay, I can do it if you want. Should I solve it again? Okay, fine, fine. So option A is the correct answer. Shall I proceed now? Fine. So you can try this again, a simple question. I'll give you 2 minutes. Maybe you can give me the answer. So this dot represents not gate. Anyone? Okay, someone has got B, so I'll try to solve it directly. So we know that this is A bar B bar, this is again A bar B, A B bar and A B. So Y will be nothing but A bar B bar C plus A bar B C bar plus A B bar. So I am adding C plus C bar here to get all the terms. So it will be A bar B bar C plus A bar B C bar and then A B bar C and then A B bar C bar. So this is nothing but 0 0 1. This is nothing but 0 1 0. This is nothing but 1 0 1. This is 1 0 0. So y is nothing but summation m 1 2 4 5, which is option B. Yeah, B was the answer. Yeah, so option B is the correct answer. I hope all of other students are getting it. These are quite simple questions, and you need to have a good understanding of the multiplexer and multiplexers. So let me proceed with some other question. Yeah, maybe you can give me the answer of this, so I'll write it clearly. I guess it is not clear. So this is 0, this is D, then this is again 0. So I'm only pointing out the D's here. This is 1. Rest of them are 0. Shall I solve it or you are trying? Okay, I'll give you 2 minutes. Maybe you can get the answer. So I1, this was 0 0 1. Then this I3, 0 1 1. This I6, 1 1 0. Anyone with the answer? Okay, let me solve it then. I1 we are getting D, so Y is A bar B bar C and then D. Then for I3 we are also getting D, A bar B C and then D. And then for I6 we are getting 1. So 1 is nothing but D plus D bar. So we'll have four minterms in the output, which are these A B C bar D and then A B C bar D bar. So let me try to change the color. This is 0 0 1 1, which is 3. This is 0 1 1 1, which is 7. This is 1 1 0 1, which is 1 1 is 12 13. And then this is 1 1 0 0, which is 40, no, 12. So it is y is nothing but summation of minterms 3 7 12 13, which is option B. Yes, so option B is the correct answer. Is it clear to everyone? Please respond if it is clear. Okay, so option B is the correct answer to this question. So we shall proceed now. Okay, so this is quite a long question. Maybe you can do this as a homework problem. We'll solve this question in the next lecture. So you can note down the input. So we have a 8 cross 1 mux. We have certain I knots given. Let's suppose till I7. We have ABC as select lines, and then we need to calculate. Okay, so I naught are also given. So we need to calculate the output or the Boolean expression are given by these two, A and B. You can note down these values and we'll solve it in the next session. This will be the first question of the next session, then we'll proceed to number systems. You can note down the question and we'll proceed with this question. Tell me once you have noted all the values so that I can proceed with the next question. I'll write them fast. I1, I2 and I7 are 0. then I3, I5 are 1, then I0, I4 are D, I6 is D bar. This is for option A. And for B, I1, I2 are 0, then I3, I7 are 1, I4, I5 is D, and then I0, I6 is D bar. Have you noted these values? Please respond if you have noted these values so that I can proceed further. Okay, so let's proceed with some of the shorter questions. So this is a question, you need to calculate f in this question. I hope it is visible. Yeah. Can you tell me what is this 4 cross 1 mux giving? I'll give you 2 minutes. Anyone with the answer? Okay, if not, I'll solve it. So, okay, my bad. Okay, XOR is the answer that you are getting. So 0 is the input given, so not will give it 1 and then it will be again 0. So this will be again 1, 1 and then 0. So f will be nothing but 0 into p bar q bar plus 1 into p bar q plus 1 into pq bar plus 0 into pq. So these two terms will get cancelled. Then pq p bar q plus pq bar. So it is nothing but XOR. So option D is the correct answer. Yeah. Let's do few more questions. Is it fine? Shall I proceed? Okay. I hope it is clear. So I'm proceeding. So again, the output of this circuit. So let's try to solve this. Mm, yeah. So here the select line is 1. So it will be 0. It will be 1. So x will, it will be 1. You can also solve side by side. So it is 0 now. So 0, it will be 1, 0. So a will be x. It will be 1. So 0, 1. So output will be x. Okay, so here you can see the select line is 1. So the invert of this will be 0. Okay, sir, it is possible to. So you are telling about this year assignment? Assignment 4 of this year? Okay. So fine, I'll do it in the next session. I'll remember this question 9 and question 4 you are having doubt. So next session might be preponed to maybe this Friday only. So I'll be taking session on Friday, I guess. So I'll explain these two questions if you will be there uh, in the session. Fine. So for this, you know the select line is 1, so this will be 0 1, it will be 1 0, it will be 0 1. So 1 is the input to this, then again x is the input to this, and so this is quite basic. So output will be x only. Option B is the correct answer. Is it fine? I'll close the session in maybe 2 3 minutes. So Shall I proceed? Okay. Again, we have a okay. The question is same, I guess. It is repeated. We can leave this. Fine. Then, yeah. So, anyone having any doubts? We have covered quite a lot of questions for mux and demux. I hope it is clear and it is useful for you to solving the assignments. Is it fine with everyone? Shall we close the session? So you might get a notification regarding the preponement of the session. Yeah, it is not for sure on Friday, but the NPTEL will let you know that when the session will be held. So if the session will get preponed, so I'll be taking the next session on Friday, I guess. It is not clear, sure as of now. So NPTEL will let you know that when will be the next session for this particular Tuesday session. So we can close this session, I guess now. Yeah. Thank you for joining. I hope it is useful. Yeah.